So, okay, good morning to everyone. So, today we'll start discussing about the topic that is the TCP protocol. Now, TCP stands for the Transmission Control Protocol, and this is the most widely used protocol for data transmission and in data transmission in communication network, such as internet. So basically, it is the most widely used for data transmission and communication. Data transmission in communication, this protocol is used in the internet mostly. And TCP is basically provides process to process communication. This basically provides process to process communication. So this is the definition of the TCP. Now we will see the features of the TCP. So the features of the TCP that are is the process to process communication. So this is the features that this is the process to process communication and uses the port number for communication. So for any communication happening, it uses the port number. And TCP uses the numbering system. So this is the features that the TCP use the numbering system. Now, why this numbering system is used? Now, this numbering system is used basically to keep track of the segments, that are to be transmitted or received. Now, that means the segments that are present, to keep the track of it, that how many segments are transmitted or how many segments are received, that to keep the track of that segment, the numbering system is used. Now, inside this numbering system, the number used are first, there are three types of numbering system used. One is the byte number, another is the sequence number, and third type is the acknowledgement number. So first we will see what is the byte number. Now, byte number is basically all the bytes of the data that are transferred, all the bytes of the data that are transferred with the help of TCP are numbered. Means the data that is transferred, the bytes of that data, we number it using the TCP. So all the bytes of the data that are transferred with the help of TCP means the data, the whole data that is transmitted, or we can say that is transferred with the help of TCP. That data's all the bytes of that data, we numbered all the bytes of the data. How this numbering we can start? This numbering we can start with started within the arbitrary number. Means we can use any number. It is up to you that which number you will use. That means its numbering can be with the arbitrary number. Next is the sequence number. The next second type is the sequence number. Now, what is the sequence number? It is the number which is assigned to each segment. Means this number is used. This number is used to assigning each segment. For assigning each segment, this sequence number is used. Now, which segment? That particular segment that is transmitted. That particular segment that is transmitted. So that's why it is said that it is the number which is assigned to each segment that is transmitted. Means the segment that is transmitted, the segments that is transmitted, we numbered it. And this is called the sequence number. Now, sequence number for each segment. Now, sequence number for each segment is the number of the first byte of the data carried in the segment. Means sequence number will be what? that each segment that is present, each segment's first byte of the data means the data which is carrying, the segments, the data which is carrying, first byte of that, the sequence number of that segment, that the sequence number for each segment is the number of the first byte of the data that is carried in the segment. And the acknowledgement number, what is the acknowledgement number? It is nothing, but it is the numbering which is given to acknowledgement received from the receiver. So this is the numbering given for the acknowledgement. Now the acknowledgement is what? The acknowledgement that is received from the receiver. For numbering that particular acknowledgement, we use the acknowledgement number. So this is the features, the numbering system features. That first, what we have seen, first is the our byte number, all the bytes of the data that is to be transferred with the help of TCP. All the bytes of the data that are transferred with the help of TCP are numbered, and the numbering are started with the arbitrary number. Next is the sequence number. So sequence number is used for what? Giving each segment, assigning each segment, we uses the sequence number. Now these segments are transmitted. So assigning each segment that is transmitted, we use the sequence number. And this sequence number is for each segment, the number of first byte data carried in the segment. And third was the acknowledgement number. And this acknowledgement number is given for what? When the receiver, when from acknowledgement is received from the receiver, that particular acknowledgement, we give a number. That is the acknowledgement number. We say that number will be the acknowledgement number. Now, the next feature is the flow control. Now, you already know about the flow control because in the first starting time, we also seen about the flow control statement. Now, flow control is what? Here in TCP, the flow control is that in the sending side of the TCP, there is a we have a client and the server, or we can say sender and the receiver. So in the sender side, sender and the receiver is present. So the TCP that present in the sender side control how much data should be sent, how much data that should be sent, so that the receiver can easily accept that data and process it. This is the flow control, that how much data we should send to the receiver so that the receiver can that data or accept that data. This is the flow control. So sending side of the TCP control that how much data it should transmit so that the receiver can easily accept it. Because if it is overloaded, because if the data, we send many data and the receiver become overloaded, then there is a chance that it may lost, that the packets go lost. So that is why the flow control is used. And last is the error control. Not last type, there is also congestion control present. So error control is what we already know. For error detection and correction, we know that error control is used. So TCP is what? TCP is a very reliable protocol. We said TCP is a very reliable protocol, and error control is for error detection and correction. This is used. And congestion control, what we have already seen in the previous classes, that congestion control, that's why this is the congestion control occurred in the TCP. So this is the features. This is the features that present in the TCP. So now we will see a thing that we known as the three-way handshaking. This is the thing, that the three-way handshaking. So what is the three-way handshaking? Now, before sending data, we have to make a connection. Because if we didn't make a connection, then the data cannot be transmitted. So three-way handshaking states that it is the connection establishment in TCP. That means before sending a data, connection should established. So three-way handshaking states that it is the connection establishment in TCP. Now TCP is the connection oriented protocol. TCP is the connection oriented protocol. So this is connection oriented protocol. That's why TCP is very reliable protocol, because it is the connection oriented. And this is connection oriented basically for that it uses the three-way handshaking. This three-way handshaking is used. Now, for connection establishment or as well as for the connection termination in TCP, three-way handshaking is used. So this three-way handshaking is basically used for connection establishment and connection termination. For both we uses the three-way handshaking. Now, three-way handshaking means that what I am saying, that before sending the data, we exchange some packets. Before sending the data, we exchange some packets so that a secure and a reliable connection can be established. That means before we send the data, we exchange some packets. So exchange some packet means what? For exchanging packets, it is used to secure and reliable connection can be established. So by exchanging some packets so that a secure and reliable connection can be established. That is called the connection oriented. That means before sending the data, connection is established. Now, there is a client and a server present. So, client and server, the client present and the server present. Client and server both send data to each other. Now, if you remember, one time I have said that there are three types of transmission communication. That is half duplex, full duplex, like this. So that is why two-way communication is possible. So that means two-way communication is possible means it is the full duplex mode. We can say it is the full duplex mode because there is two-way communication. So that's why, because from sender to receiver we can communicate, and from receiver to sender we can communicate at the same time. So that's why it is the full duplex mode. So client and server both send data to each other and it works on the full duplex mode. Now, through our diagram, we will see what is the three-way handshaking and how it can be done. So let's say there is a client present and there is a server present. So in this side, there is a client and in this side, there is a server. So first what client will send a synchronous packet. Client will send sync packet, or we can say this is SYN, or we can say this is the synchronous packet or sync packet. We can say that client will send some sync packet. Client will send sync packet or synchronous packet with setting the flag. As this is the flag. So setting the flag as S. And now you see it gives a sequence number. When it is sending the sync packet with setting the flag S, it gives a sequence number. Let's say we have said that the sequence number, it can be an arbitrary number. So let's say an arbitrary number is given, that is 6,000. This arbitrary number, the client send sync packet with setting the flag S, and with sequence number, a sequence number is given with 6,000. So this sync packet goes to the client side. This sync packet goes to the the sync packet goes to the server side because client is sending. So client send a sync packet with flag S and a sequence number it choose as a 6,000. Now it goes to the server side. Now, after receiving this, server will do what? Server will send own sync packet. Server will be send own sync packet and acknowledgement of this sync packet to the client. You see, that's why server send its own sync packet plus acknowledgement A. That means server send its own sync packet with the acknowledgement of this packet, this sync packet, which is received by the client to server. And this time it set a sequence, that is sequence number, that is 10,000. It sets a sequence number as a 10,000 because this sync packet, for this sync packet, it uses this sequence number. It set this sequence number. And there is also acknowledgement number is given. You see, there is the acknowledgement number given. Now, acknowledgement number will be what? Acknowledgement number will be sequence number. This is for this acknowledgement number it is given. So here the sequence acknowledgement number will be sequence number plus 1, because this acknowledgement we are giving for which sync packet? This sync packet. So that's why its sequence number is 6,000. It is the acknowledgement of this, so we are sending the acknowledgement, so we send it with the 6001 as a 6001. We give the number as a 6001. And RWND, that means receiving window size, so it will send also the receiving window size number, and it is also the arbitrary number. So that means first the client will send a sync packet with setting the flag F and given a sequence number to the server. Server will then do what? Server will send its own sync packet, with setting the flag as S, and for that it give a sequence number, an arbitrary sequence number it given, that is 10,000. And with this, server also send an acknowledgement packet. Now acknowledgement is for what? Acknowledgement will be the sync packet which is received from client to server. For that, it will send the acknowledgement. And in this case, the acknowledgement number will be what? The acknowledgement number will be the sequence number, from client to server, the sync packet sequence number which is given, that sequence number plus 1. So for that, it is 6,000. Here we are writing 6001. And RWND, that is the receiving window size, and it will also send the receiving window size, that is, let's say it is given 5,000, so it will send here. Now after receiving that, after receiving this, the client will do what? Client will again send an acknowledgement. Now this acknowledgement is for what? This acknowledgement is a sync packet, this sync packet which is sent from the server to the client. So that means this acknowledgement, it is give this acknowledgement, it will be from client to server for this sync packet which is sent from server to client. Now that means what? That means its acknowledgement number will be what? Its acknowledgement number here, it is 10,000. So that means sequence number plus 1. So that's why we use 10,001. And in this same sequence number, previous packet which is sent from client to server, same sequence number it uses, from sequence number 6,000, and it will also send a receiving window size to the server. So that's why after that completing, it will send to the server. So after receiving, the data transmission will be started. So that's why you see, if we number it 1, 2, 3. So after 1, 2, 3, we started the data transmission. So that's why we can say it as the three-way communication, or we can say this is the three-way handshaking. So this, for this 3 ways, and after doing these 3 ways, the data transmission will be started. So that's why we called it as the our 3-way handshaking. Okay. It is clear to everyone?
Yes, sir.
ओके, और बाकी सब लोग को समझ में आया कि 3-way हैंडशेकिंग क्या है?
Yes, sir.
Yes, sir.
Okay. So this is basically the 3-way handshaking, and this 3-way handshaking is very, very important. This 3-way handshaking is very much important because TCP is the most important topic in our in networking. So always, if you give some, if you want to describe this our 3-way handshaking, if some question is given, describe the 3-way handshaking, then do this diagram and explain like this. So explain step by step. This is very much important. So this is for this, we can say this is the we can say for the data transmission. So we have already said for 3-way handshaking, this is the, we can say this is for the connection establishment. This is the 3-way. Before starting the data transmission, this is the connection establishment. So after connection establishment, the data is transmitted. So after connection establishment, the data we can transmit. Now, same as that for connection termination, because we are saying for 3-way handshaking in TCP for connection establishment as well as connection termination in TCP, 3-way handshaking is used. So here I am not describing the termination process. The termination process is same, only a finished flag is used. Only there is same. This diagram will be same, only a finished flag. There will be the flag present, that is the finished flag. So same as that, the same diagrams applicable for the termination also, only a small change will be happen. There will be a finished flag present. So this is all about our 3-way handshaking. Now, after completing the 3-way handshaking, we will move for the TCP segment. We will move for the TCP segment. Now, a packet in a TCP is called the segment. So we have already seen for the IPv4, for the IPv6 format. So now we will see for the TCP format also. Now in TCP, there is the, like this, it will be present, and here first will be the header and next will be the data. So header's length will be from 20 to 60 bytes. Now we will show the header format. We will show the header format of the data. So okay, so now we will see the header format. So how the header format will be? Let's see the diagram. So this will be clear. So what will be the header format of the TCP? So in TCP, the header format looks like this. First, there will be the field that is the source port address. The first field will be the source port address. Now, source port address is for source port address and destination port address. So source port address is basically used for the port of the source port number of the application of the source. We can say this is the port number. This is the port number of the source. The source port is, this is the port number of the source, and here the port number of the application of the source, or we can say it is the port number of the application that is present, the port number of that application of that source. And destination port is what? This is the port number for the destination, or we can say the port number of the application that is present on the destination. So this is the source port and the destination port. So source port will be the 16 bytes and destination port will also be the 16 bytes. After that, there is a field that is sequence number. The sequence number which we have already discussed, that is that sequence number. That why it is used, this sequence number is used to assign the first byte of the data. To assign the first byte of the data, we uses the sequence number. And acknowledgement number, this acknowledgement number is what? In the three-way handshaking, we have already seen that the acknowledgement number is given. So why this acknowledgement number is given? It is the number of byte number. It is the byte number that the receiver of the segment is expecting to receive from the other party. Now, generally, what we do? Generally, we do that the acknowledgement number will be sequence number plus 1. That means you see this is the, or we can say this is our acknowledgement number. You see this is the sequence that is given. First this sequence, and this acknowledgement, when server will send this acknowledgement to client, then you see it is going acknowledgement as 6001. That means sequence number plus 1. It will be sequence number plus 1. Okay, so this will be sequence number plus 1, the acknowledgement. And why, which, for which this field is used? It is the byte number. It is the byte number that the receiver of the segment is expecting to receive. Receiver of the segment is expecting to receive from the other party. And generally, it is the sequence number plus 1. Generally, it is the sequence number plus 1. Okay, so this is all about the our acknowledgement number. Now, after that, there is HLAN field. So we already know that what HLAN field is used. HLAN field is used for the header length. This field is used for the header length, and it is of the 4 bytes. After that, there is the reserved field. Now, this reserved field is the 6 byte. This reserved field is the 6 byte. Now, this field is basically used that for some field which are reserved for the future. Let's say some fields are present that are reserved for the future. This field is used to store that, this reserve field. So, and this reserve field is of the 6 byte. And after that, you see 1, 2, 3, 4, 5, 6. So this 6 are some control fields. So some control fields are present. Now URG means urgent. ACK means acknowledgement. PSH that means push. RST that means reset. SYN that means synchronous. FIN that means finish. So these are the control fields. These are the for control. Using the control, we uses these fields. This is the control fields we use, and each of it are the 1 bytes. Each of it is the 1 byte. And after that, there is the window size present, window size field. Now, what is the purpose of using this window size field? Now, this field defines the window size. Defines the window size which sending in the bytes. That means this defines the window size of the sending TCP. That the TCP that is transmitting, that sending TCP, it defines the window size of that sending TCP in bytes. And after that, there is the checksum field. So we already know that why the checksum already I've done in the classes. Checksum is used for error correction. So error detection and correction, we uses the checksum. So checksum is used for the error. And urgent pointer, this urgent pointer is field is used to valid only if the urgent flag is used. Means if the urgent flag is used, then we use this urgent pointer field. And after that, there is a field present that is options and padding. So this field is present for options, and if we, for the doing the padding, these fields are present. So this is the header format. This is the header format that is present for the TCP. So for TCP, there will be the source port, destination port, then sequence number, then acknowledgement number, then header length, reserved, some control fields like URG, ACK, PSH, RST, SYN, FIN, and this all control fields, it will have some name and have some uses for this. And after that, there is the window size, and after window size, there's the field that is present for checksum, an urgent pointer, and this field for the urgent pointer is used if the urgent flag, that means if this urgent flag is set, then the urgent pointer is used for valid this urgent pointer. Okay, so if this urgent flag is set, then only this urgent pointer will be valid. Otherwise, it will be not valid. And after that, there is a field present that is options and padding. So this is about the header format of the TCP. Okay, it is clear to everyone?
Yes, sir.
Okay. So in the previous class, I think I have missed a thing. So in the subnetting concept, I have missed for discussing a thing. That is, I didn't remember that I have not, for supernetting, I have not discussed. For supernetting, let's say I have not discussed with you. Only subnetting I have discussed. One thing I have not discussed with you during the IPv4, that is the supernetting concept. Let's say I have remembered that this concept I have not discussed with you. The supernetting, I only said that this is the reverse process of the that subnetting reverse process, but I didn't show you how it can be done. I didn't show you. So let's discuss about that. That this supernetting is basically in this an organization can combine several class C blocks. In this an organization can combine several class C blocks to create a large range of address. That means here that I have already said that supernetting is the concept that several networks. So we have several networks will be present, and these several networks are combined to create the super network. So several network we will combine and create the super network. Now, in case of subnetting, we see the number of ones in the mask. In the mask, the number of ones that is present increases. But in supernetting, the number of masks decreases. And supernet mask is what? It is exactly the reverse of the subnet mask. It is the reverse of the subnet mask. So the formula we have already used for subnetting, that is n sub equal to n plus log 2 base s. This formula we have used, but in case of supernetting, this formula is used, n super equal to n minus log 2c. Now this n super is what? This n super is the length of the supernet ID. This n super is the length of the supernet ID. And this n will be the length of the net ID. And this log 2c, this is the number of class C blocks that are combined to form the supernet. So let's say our default mask. Now we are using class C. We are using class C. So that means class C means what? Our default mask. that will be 24 bit, we can say the 24 bits of the net ID and 8 bits of the host ID. So 24 bits net ID means n equal to 24 and 32 minus 1 n, that is will be 32 minus 24, this will be 8. So that means 24 bits will be net ID and 8 bits will be the host ID. So 24 bits 1 will be followed by 8 bits 0. So our default mask will look like this. Our default mask that will be look like this. You see 24 bits 1 followed by 8 zeros. Let's say we are breaking it into 8 subnets. So first we will, let's say we will break it into 8 subnet. So if we break it into 8 subnets, that means our we use this formula. So when we use this formula, n will be 24. So we give the value 24, and s is number of subnets we are dividing. So 8, that means log 2 base 8. So there will be 27. So that means 27 ones will present in the subnet mask. So the subnet mask will look like this. The subnet mask will be look like this. Now you see, previously 24 ones are present in the mask, but now it becomes 27. So that means 27 ones, 3 ones increases when we do the subnet masking. But in case of supernetting, we will see, you see, when we will do the supernetting mask, that means supernetting will, it combines several network to form a super network. So here this 8 class C will form the supernet. So if we uses this formula, you see, then 24 minus log 2 base 8, there will be 21 ones present in the supernet mask. So during subnetting, we have seen that number of ones increases. During subnetting, number of ones increases and the host are also increases. But when it will be decreasing, because that time it is 27 ones. Now you see we are using 21 ones here. So this is the difference. When we use the subnetting, number of ones increases as well as the number of hosts in the number of hosts that is present also increases. But here in the supernetic concept, the number of ones decreases and the number of hosts are also decreases here. So this is the concept of our supernetting. I have not discussed that. So now I remember that there is a thing which left. So this is about the supernetting concept. It is clear to everyone? It is clear?
Yes, sir.
Okay. So this is all about in today's class. In the next class, we will use, so TCP we have already seen. Another protocol we will see, that UDP, user datagram protocol, and through user datagram protocol, this is the connectionless protocol. TCP is like that, it is the connection oriented, but UDP is the connectionless protocol. So we will see it